Master's student Computer Science. I'll be presenting a paper review on titled Unsupervised Algorithms to Detect Zero-Day Attacks, Strategy and Application. The authors are Tommaso Zoppi, Andrea Casarelli, Andrea Bondavalli. The contents are shown in this slide. The abstract of this paper introduces the problem of 0 days and reviews unsupervised algorithms for their detection, which was well covered. When we look at the review of the abstract section, overall the paper exemplifies how to practically orchestrate and apply an appropriate methodology, process, and tool, providing for even non-expert users a means to select appropriate strategies to deal with zero days. the introduction to this paper it clarifies the concerns in the security domain about the adoption of supervised machine learning to defend against known threats and how they are embedded into antiviruses or IDSs, which aim to detect attackers that exploit known security breaches. It also introduces the use of unsupervised anomaly detection algorithms to first model the normal behavior of a system, then use this knowledge to find patterns in the data that do not conform to the model. These patterns are called anomalies. This section was concise and it provided a deep and thorough definition of the key terms such as the algorithms that are used for anomaly detection. Section 2, which covers the problem of zero-day attacks. This section defines the key terms in the domain. It explains the cost implications of using proactive zero-day exploits in comparison to the use of cost-effective measures such as antiviruses. It also indicates the potential benefits of research for solutions to these unknown attacks to the industry and academia. It also shows that unsupervised machine learning models are supposed to synergize with supervised ML algorithms due to the optimal performance issues of unsupervised machine algorithms. Section 3 covers the anomaly detection algorithms for unsupervised intrusion detection. And it discussed the algorithms such as clustering. It also discussed classification algorithms, statistical algorithms, angle-based unsupervised algorithms, neighbor-based algorithms, and unsupervised neural networks. It also showed that the data points for clustering algorithms that cannot be assigned to any of the existing clusters usually indicate anomalies. And also to note, clustering and statistical algorithms usually perform better at processing time of tasks because they perform linearly. Section 4 provides best practices and uses some research questions that drive quantitative analysis in unsupervised algorithms. And this section provided an in-depth picture of the metrics for detection of the performance gathered from the algorithms, tabularly and also graphically. And the paper measured and ranked detection performance of metrics by F-score and Matthews correlation coefficient. And we also see that monitoring activities were either event-based or time-based, which influence the semantics of features and interpretation of the values. Section 5 was covering the tools tailored to perform the analysis. And the section was adequately covered, talked about tools such as Reload, PyTorch, TensorFlow, Scikit-learn, among others. And also, the paper indicated that there's not a single tool that offers a complete set of unsupervised algorithms through a user-friendly interface. However, the research team utilized Reload software, which is open source, and possesses 17 different unsupervised algorithms for this task. In section 6, the it covered the quantitative comparison of the results, which they used the most recent data set, which is SDN20, which contains 5 types of attacks, which were analyzed for 0-day attacks. It is worth noticing that the different algorithms exhibited different metric scores, and that algorithms belonging to specific families often show similar behavior. And noticeably, boosting COF achieves precision recall F2 score and MCC of the values indicated 0.997, 0.994, 995, and 0.986, better than other algorithms. And this section as well covered by the authors. And in conclusion, the study shows that it is possible to derive an unsupervised anomaly detection algorithm built on boosting meta-learning, which has much better detection performance than regular unsupervised algorithms and is robust to zero-day attacks. For the lessons learned to adopt in my group project, will be modifying of categorical features to become more meaningful for anomaly detection in my dataset, and the identification of patients likely to experience drug resistance. And then also we shall train the test data to identify patients that are performing well with their medication, and those that do not appear in the training dataset will be considered to be failing. We shall also use GUI tools such as Waker or Reload to improve the anomaly detection due to their user-friendly features and the composition of algorithms. And in addition to the supervised algorithms such as SVM, we intend to implement boosting unsupervised algorithms such as SDO, COF, to assist us in detecting these patients whose scores tend towards drug failure. And with that, I thank you very much.